Okay, here is practice 15b, dealing with the functions of acids and bases and how they interact in solution. So the way we're going to do this is, first thing we're going to do is practice our dissociation equations for acids and bases, and we're going to remember that anytime we have an acid that has a hydrogen attached, it doesn't matter if it's a binary or an oxy acid, it's always going to dissociate right down the middle. It doesn't matter if it has more than one hydrogen, so that our dissociation products will always be hydrogen and something else. Same is true with bases. We'll get to that in a little bit. So I'm going to write a dissociation equation for all of these acids, and I'm just going to unzip them down the middle so that our products for every dissociation will always be hydrogen. And of course, whatever's left. It's not necessary for you to write the charges, but I always do, just because it makes it easier when we get to the next part, which is, of course, neutralization. So I'm going to dissociate each of these just by unzipping them down the middle, and one of the products of this dissociation is always going to be hydrogen. It doesn't matter if there is a subscript, it just means you have more than one hydrogen. So here is two hydrogens. What's left is the sulfate, which of course looks like this. And lastly, this one has three hydrogens. This subscript tells us it has three hydrogens. And that's how we do these. And bases are done identically. Whenever we have a base, one of the products always has to be OH minus, otherwise known as hydroxide. So whenever we dissociate one of these, we're going to do it in such a way that one of our products is always hydroxide. So I'm going to dissociate this one right down the middle. And one of our products is always going to be hydroxide. It doesn't matter if there's one or more than one hydroxide. We just want to make sure we're writing these dissociation equations so that hydroxide is always a product. That subscript tells us that this one has two hydroxides. And this subscript tells us that we have three hydroxides. So every time I dissociate these, I'm leaving hydroxide as a product. Okay, we're going to use these for writing our neutralization equations. And here's what we want to remember. Neutralization is just a double displacement reaction. And let's remember that all the way back in Chapter 8, a double displacement reaction was simply a reaction between two ionic compounds. A compound A and X, and a compound B and Y. And they're just going to unzip down the middle, and when they do, our new products are going to be BX and AY. Doesn't really matter the order. So we're disassembling them in the first part and reassembling them in the second part with opposite arrangements. So when we did this with precipitation, for example, if I was going to ask you to write a dissociation equation between, say, for example, these two compounds, and we said that these are both ionic compounds, and we're going to dissociate them. We're going to take A, that's going to be our sodium, and Y, that's our chlorine, and put those together. We're going to take calcium, that's our B, and carbonate, and that's our X. And all we did to reassemble these is pay attention to their charges. Calcium's got a charge of 2+, because we know from our periodic table that it comes with a charge of 2+. If we go all the way back to this chart, you'll see right here calcium's in one of those groups that always has a charge of 2+. Carbonate is a polyatomic ion, which happens to have a charge of -2. So when I'm doing these, it's pretty straightforward to write the formulas, because we're just going to drop and swap. I won't bother you if you leave the subscripts in, but let's remember that when something has a ratio of 2 to 2, it's also 1 to 1. It just makes it a little easier. What's left is our A and our Y, and I'm simply going to put those together, Na with a charge of +1 and Cl with a charge of -1, and we don't need subscripts when everything's 1. All right? We did that in chapter 13. We're going to do the exact same thing in chapter 15, except one of our reactants is going to be an acid, say for example HCl, and the other one is going to be a base, say sodium hydroxide. We're going to assemble our A and our Y, so I'm going to put those together over here, H and OH. Let's remember that if you're writing two H's and an O, it's H2O. What's left is our B and our X. And remember that I don't need to worry about writing subscripts when everything's 1. All right? This is an acid, and this is a base. This is water, and this is what we're going to call a salt. And all a salt is a positive ion with a negative ion that doesn't do anything. It doesn't have a pH, it doesn't have a charge, it doesn't have anything. It's just totally neutral and doesn't do anything. So when we are writing our products, let's remember this one rule, that the product of a neutralization reaction between an acid and a base are always, and I want to make sure we're very clear on this one, are always a salt, which just means a neutral ionic compound that doesn't do anything, and water. And let's remember that neither water nor salts are acids or bases. We've removed any acid or basic tendency. So what we're going to do is we're going to try to fill in the blanks of these following neutralization reactions, and we're going to do it by remembering that our HCl is our acid, and it's going to be our A and the X compound. Our sodium hydroxide is our base, and it's going to be our B and our Y. And our products are always going to be B and X, and A and Y. Well, I've already put together the A and the Y. The A is our H+, and the Y is our hydroxide. So this is just another way of saying H and OH, and we're just rewriting it as H2O. What's left is our B and our X. Well, our B is our sodium. Our X is chlorine. So when I put these together, I'm just going to write them like this, Na and Cl. I don't even need to write any subscripts because there aren't any. That's it. That's all you do. So in most of these, what I've done is given you the basics, no pun intended. And let's remember that our products are always going to be water and a salt. So in a lot of these, all you have to do to predict what goes in the blank is figure out what your B and your X are, or your A and your Y. Well, here's question part B. And it tells us that we have a base, that's this guy, potassium hydroxide, and we have a salt, potassium sulfate, that's this guy, and we have water. So what's asking us to do is figure out what goes in this blank here. Well, that's A and that's X, and that's B and that's Y. And this is B and X, and this is A and Y. So all we have to do is figure out what's going in this slot, empty slot. We have to figure out what A and what X are. Well, I'll give you a hint. Our A is right here, and that's the H. So I'm going to write that here, H. Well, what's the X? X is right here, SO4. And so I'm going to write that here. And all I have to do to figure out how many H's we need is look up the charge. Let's go back to this chart that we had in practice 15A. It says that sulfate, right here, right there, just happens to have a charge of 2-. So when we're doing this one, let's keep in mind that hydrogens always have a charge of +1, and this sulfate has a charge of -2. So I'm going to do my drop and swap, and that means I'm going to put a subscript of 2 in front of the hydrogen. So even though my A is H and my X is SO4 with a charge of 2-, I'm going to put a subscript of 2 there, and that takes care of all of the hydrogens and is the correct formula. Now, if you really wanted to impress me, you would balance this. So how are we going to do that? Well, I'm going to do that by saying that on this side of the equation there are 2 hydrogens here plus another 2 here. That means 4 on the reactant side, but only 2 on the product side. So I'll put a subscript of 2 there, and that takes care of the hydrogens. Now, if I was going to add all these up, I would say that there are 2 hydrogens here, 1 sulfur, and 4 oxygens. Here are 2 potassiums, 2 oxygens, and 2 hydrogens. On this side of the equation, there are 2 potassiums, 1 sulfur, and 4 oxygens, plus another 4 hydrogens and another 2 oxygens. So let's count them up. I see 2 hydrogens here, plus another 2 is 4. 4 hydrogens here. 1 sulfur, 1 sulfur. 2 potassiums, 2 potassiums. 4 plus 2 is 6 oxygens, and 4 plus 2 is 6. And that's all you do. All right, let's try this on part C. And this one is asking, all right, if we know that this is going to be our our A and our X, and this is our B and our Y, and this is our BX and our AY, we can save ourselves some trouble because we always know that one of our products is going to be H2O. It gives us everything. All it's asking us is, what's B? What's going to go in this slot here to hook up with this hydroxide? And it's already telling us that the charge on that hydroxide, the subscript on this hydroxide is 2. That means there's 2 hydroxides. So I need something that's going to fit in that slot with the hydroxide and have a charge of +2. I think barium will do it, and barium just happens to be right here and have a charge of 2+. I think that's going to be our good pick. Let's go here. So what I'm going to say is, and I'm going to put barium in this slot. And then I'm going to balance this equation because what we know is that there are 3 bariums here. So I'm going to put a 3 next to this barium. And because I know that there is a subscript of 2 by this phosphate, I'm going to put a 2 here. And because there are now 6 hydrogens here plus another 6 here is 12, I'll put a 6 here. Okay, last one. We're going to save ourselves some time because we know one of the products is always going to be water. Here is our A and our X and our B and our Y, and this is going to be BX and AY. So what's going to be our B and our X? There's our X and there's our B. Aluminum. And because nitrate has a charge of -1, there's going to be 3 of them. Ladies and gentlemen, all you have to do is balance the equation. So here's what I know. On this side of the equation, there are 6 hydrogens. Well, there's already 3 over here, so I'm going to put a 3 here. And that takes care of these nitrates because there happens to be a 3 here. And it looks like all the aluminum's balanced, so let's count them up. 3 hydrogens plus 3 nitrogens and 9 oxygens, plus 1 aluminum and 3 oxygens and 3 hydrogens. On this side, 1 aluminum, 3 nitrogens, 9 oxygens, plus another 6 hydrogens and another 3 oxygens. Here is 3 hydrogens plus another 3 is 6. 6 hydrogens there. 3 nitrogens, 3 nitrogens. 9 plus 3 is 12. 9 plus 3 is 12, and 1 aluminum. And that's all you do. So there's going to be a quiz on this on Thursday of this week, and this is a good way to study, so be ready. All right, see you tomorrow.